Good afternoon. Welcome to the PENC webinar series. Thank you for joining us today. My name is Katie Cox. I am the PENC Membership Director and will be serving as moderator for today's presentation. If you have any technical difficulties, please use the chat box and I will try to assist you. We will be taking questions at the end of the presentation today, and you can use the questions box to type those in. Today's presenter is Aaron Lowell with StormTrap. Aaron has 9+ years of experience providing custom stormwater site solutions for engineers, contractors, and owners in the Mid-Atlantic and Southeast regions. In addition to stormwater management, he has also provided custom precast concrete products for the oil and gas industry in Texas. A graduate of the University of New Hampshire in civil engineering, his passion for stormwater started at a young age, experiencing the ocean and pristine lakes in his home state of Maine. Aaron enjoys traveling and has lived in Baltimore, Houston, Atlanta, and currently resides in Charlotte. Aaron, thanks so much for being with us today.
Thank you, Katie. Okay, well, I'll go ahead and get started here. First of all, I'd like to thank the professional engineers of North Carolina for hosting StormTrap today. My name is Aaron Lowell. I'm the territory manager for StormTrap for North Carolina and South Carolina. I've been with the company for just over 2 years. When I came on board, I actually lived in Atlanta, close to the new Atlanta Braves Stadium. And then after about a year, StormTrap decided to split up my territory, and I made the decision to move up to Charlotte. I currently live right on the state line in the Tega Cay, Steel Creek area, for those of you that are familiar with Charlotte. Today, we're going to be talking about how precast concrete solutions can be used to help solve flow attenuation and treatment goals. But first, I'm going to start by telling you a little bit about our company, StormTrap. We're a pretty small company. We have about 50 employees. We are headquartered in one of the suburbs of Chicago called Romeoville. It's about a half hour from the Chicago Midway Airport down Interstate 55. Most of our employees are located in the Chicago region, but we have sales folks spread across the country. The original idea for the product occurred in 1998, and this is the kind of the story that's been relayed to me, but a civil engineer met with Utility Concrete Products. They are a major precaster in that Chicago Midwestern market. They met with Utility and came up with the idea to manage water underground with a modified 6x14 telecommunications vault. So they had the idea to put blockout windows in the side to make it more efficient, and they were able to get the idea patented, which is kind of crazy because who would think you could patent a concrete box design, but they did it, and the product became a company in 2001. We currently are able to service projects anywhere from a couple precast concrete modules with a couple hundred cubic feet all the way up to 1 million cubic feet or more. Really, the size of these basins, there's no limit to them. So currently working on many projects with hundreds and hundreds of pieces, and you'll see that here as we get through the presentation. We don't just operate in the United States. We're an international company as well. We're pretty active in the Ontario province of Canada. We're looking to expand into Quebec and also into Western Canada as well. But on this map right here, all of these countries shown in blue are where we have license and patent agreements. And if you go on YouTube real quick and type StormTrap, you're going to see a couple time-lapse videos in probably Malaysia and Australia. So I encourage you all to go on social media and check us out. So the company didn't expand to the Southeast region until probably the 2005-2006 timeframe. This is a map of our local installations in the Carolinas region, and you're going to see that the vast majority of these systems are in North Carolina. And one of the reasons for that is because the modules have been produced in the Raleigh-Durham area. We work with a company called Lindsay Precast. They are the company that we send the steel forms to pour the precast modules. They are located about 20 miles north of Raleigh, up Route 1, kind of near Wake Forest in a small town called Franklinton. We also have the ability, as of 2 years ago, to produce the modules in Rock Hill, South Carolina. So that has helped us tremendously with the business in South Carolina and the Charlotte area. And within the past 5 months, we've gained another precaster in the area in Richburg, South Carolina, which is about halfway between Columbia and Charlotte. So we have a couple different options. So we're really excited to see how those 2 factories in South Carolina can help us grow the business, not just in Charlotte, but also South Carolina as well. So many reasons why a civil engineer might decide to manage water underground. I can give a couple examples. One, if you're designing a site that's near an airport, I know that bird strikes are a constant problem, so it might be best to put the water underground. I can give another example. Here in Charlotte, I see a lot of townhouse and multifamily projects, and there's just not a whole lot of space. I can think of one project now where the land area of the project is completely filled up with townhouses, and then the only other thing in this plan view is a storm trap system. So if they were, if they decided to provide an above ground pond, for instance, they would have probably had to eliminate somewhere between 3 to 5 townhouses. So there's certainly some good benefits. When you decide to put the water underground, there's less pests like mosquitoes and snakes, and in the coastal areas, alligators and things like that. So some of the applications where our solutions can be used, detention and infiltration are probably the most common. So detention systems, we do these all across the country. Infiltration systems, it really depends on the local soil types. So in Charlotte and Raleigh, the soils aren't so great for infiltration. There's lots of clay soils, don't really see a lot of infiltration. So what that leads the civil engineer to do is design an above ground or below ground sand filter. Moving on to some of the treatment-oriented items here. Stormwater LID, I'll show you how our modules can be used as a watertight system to achieve rainwater harvesting. So if you want to design a system for your client where they're going to pull water from a tank, you want to make sure that all that water is not going to leak out. So I'll show you how we accomplish waterproofing. And then some of the treatment products. North Carolina, many of our installations are underground sand filters. So we're going to get into kind of a couple case studies showing how they work technically. And then we have a couple of proprietary products as well for trash debris removal. And some of our products can be used as part of a treatment train. So if you had a hydrodynamic separator upstream of a storage system, which could be upstream of a sand filter or a rainwater harvesting system. So we're going to talk about treatment trains in a little bit. The markets that we provide these products, really the sky's the limit. Most of the projects that we work on are commercial and residential. I'll give you a couple examples. We've done some Chick-fil-A, fast food stores. Working on an O'Reilly Auto Parts right now. We do a lot of medical office buildings and schools. Our smallest sector is probably industrial, but if ExxonMobil wants to manage some water at one of their refineries, we'd certainly be willing to step in and assist them. Our volume-based solutions here, now the single trap, you'll see the shape kind of looks like a double T type structure that you'd see as maybe like a pre-stressed piece of concrete for a parking deck. Our modules are not pre-stressed, they're just regular precast concrete. The double trap system, it's basically as simple as putting 2 single trap pieces together. So you're going to see a lot of these modules here coming up. And then some of the water quality products we have. Site Saver is a hydrodynamic separator. These are effective at removing oil and grease, sediment particles from about 50 to 300 microns. So those particles are pretty small, but it's not small enough to remove nutrients like nitrogen and phosphorus. You want to look at using some type of a filtration device if you're looking to remove nutrients. Trash Trap is more of a municipal product. It's a netting technology, and that can be scaled up to the width of basically a small river. We have a system installed in LA that spans the width of the LA River with a water quality flow of 500 CFS and a peak flow of 6,000 CFS. That's really large scale trash removal. And then Pump Guard is similar to Trash Trap, except it's designed to stop things that are flushed down the toilet that aren't meant to be from damaging the pumps at an existing wastewater facility. So why precast concrete? There's many solutions. When you civil engineers are looking at different types of ways to manage water, there's many types of products that can be used underground. Well, for one, you're getting a 75-year design life. Our banners at the trade shows actually advertise a 100-year design service life. One thing that's great about precast concrete products and storm trap in general is that we can offer a 5-year standard warranty. And I've heard of certain situations where we've actually come up on that warranty and added years to it. Typical in the industry is a 1-year warranty. Small engineering tolerances. So generally the tolerance on precast concrete is about a 1/4 inch. High strength PSI concrete. 6,000 PSI is the lowest compressive strength that you're going to see on one of our drawings. And that's substantially higher than cast in place, which is typically 4,000 to 5,000 PSI. Our precasters will actually target their mix to hit about 1,000 PSI above that 6,000. So, you know, the 28-day breaks are falling between 6,500 to 7,000 PSI. Quick and efficient installation. These things can be assembled rapidly in the field, and we do have a time-lapse video a bit later in the presentation. So the steel forms that are used to produce these concrete modules are quite large. These pieces are almost 16 feet long, almost 9 feet wide. So if you get a bunch of these in a precast factory, it takes up quite a bit of floor space. So just kind of wanted to give you guys an idea, you know, without giving the full precast concrete plant tour of what these molds look like. So getting into some of the technical dimensions about the modules themselves, the two precast concrete modules or systems that you see on this slide right here are interior pieces. The exterior pieces are produced in the same form, and what we do is we block off, if you can see my cursor here on the left, we block off this cantilevered part of the roof slab, and this interior leg becomes the exterior wall. So that 8'5" dimension goes down to 6'7" for our exterior pieces. Single trap is offered in heights from 1'1" up to 7.5 feet tall. And then if you put the two together, we can go 2'2" to 15 feet tall with the double trap. All of the modules are custom engineered for each specific project. So we have the ability to accommodate aircraft load rating, for instance, but our standard design is for HS20 standard traffic loading. I've had a couple of requests where the engineer wanted to basically have zero earth cover over the top and have it as a 300 PSF pedestrian load. We have the ability to do that as well, but we generally say that our lowest grade system is going to be the HS20 loading. Taller units are always more cost effective. So if an engineer tells me that they want to go with a 5-foot storage height, I'm going to be asking if they can get 6 or 7 feet. And the reason is because for us to add, you know, a foot or 2 or 3 to the height of these modules, it really doesn't add a whole lot of cost. You're talking literally about maybe $25 to $50 of extra concrete and steel. So the best bang for your buck using these precast modules is to design the system as tall as you can. And I'm going to highlight that here when we look at our footprint with precast concrete versus some other solutions that are out there in the market. The void ratio for our tallest systems is 85 to 91%. So what that means is we can fit a lot of water in a small amount of space. Earth covers over the system, 6-inch minimum for HS20 traffic loading, and that can include flexible asphalt. On the high end, we can accommodate 30 feet of cover or more. Our precast forms allow us to increase the thickness on the slabs and the exterior walls. Here's a typical rendering of what a very generic basin would look like for a single trap and double trap. And you can see here how the exterior pieces are a little bit less wide versus the interior pieces. So analyzing our footprint versus some other solutions that are out there on the market. So if you're comparing apples to apples versus a pipe system or a chamber system, using precast concrete, we generally cut down the footprint about 25 to 35%. But there may be a situation where you're able to stack the water higher using a concrete system versus maybe a pipe system. And if I want you all to take away one thing from the presentation today, it's that we need minimal earth cover, only 6 inches. Let me give you an example. So some different diameters of pipe need anywhere from 12 inches to 24 inches of earth cover to achieve HS20 loading. I know that corrugated metal pipe, for instance, at 102-inch diameter, they bump up to 18 inches of cover for HS20 loading, where we can take it up all the way to 6 inches. So there may be situations in tight circumstances where you can stack the water higher using our system. And what does that mean? That means we can chop down the footprint by even more, maybe even a half or more. So here's an example on the bottom, 8 foot versus a 9.5 system, footprints chopped in about half there. So here is a unique set of plans from a project in Illinois. as you guys know, as the designing engineers, the contractors will look at different alternatives. Well, this engineer, decided to basically do those designs up front and include them on the plans and say, contractor, you pick. But here's just an example of how much we can reduce the footprint versus some other systems that are out there. And when you're designing I like to describe these modules as kind of like big concrete Legos. We don't have to design these systems as square or rectangular. We can come up with all kinds of unique shapes, U shapes, L shapes. I got a slide coming up in New Jersey that's really, really funky, but here's an example in Baltimore. We needed to design the system to avoid a utility. I think it was either a lamp pole base or a fire hydrant or something like that. Now, in a case like this, if you had all the space in the world, what you see here on the bottom left-hand corner isn't really a great design just because there's so many end panels. If you count them up there, I think there's like 10 or 12 panels. That adds precast concrete cost without adding any storage volume. So wherever we can, if we're adding precast, we want to make sure that they're modules and storing water. But if this is the only thing that can fit in your footprint, then it can work. So here's just a quick animation that highlights how we can come up with unique designs. If you needed to step down your storage system underneath a parking island, we generally don't like large trees to be installed on top of our system. So we do have the ability to step it down if you need to accommodate a lamp pole base or a pipe or maybe some type of a bush or a shrub or a tree or something like that. So focusing in here on single trap, these are typically installed on a stone-based foundation. However, there are limitations to it regarding earth cover, and I have a slide that highlights how much earth cover we can accommodate with that stone base. But there is the option to place the single trap modules on an 8-inch thick cast-in-place foundation. So this animation kind of flips back and forth between the different foundation options for single trap. So you can see the stone, the cast-in-place slab, and then the cast-in-place strip footings if you needed to infiltrate, but you also needed that robust foundation. Okay, so here's the slide that highlights how much earth cover we can accommodate. You're going to see that the more cover there is on top of the system, the thicker stone base will be required. And I believe we can actually get up to 8 feet with a 24-inch stone base, so we could actually add another arrow on here. We've done a little bit more engineering on these things with our third-party geotechnical engineer. But you can see the photo on the left there. That's what a single trap system looks like on a stone-based foundation. We're going to see more of that here. Okay, so moving into case studies, I have a bunch from around the United States. The vast majority are in the Southeast, have quite a few in the Mid-Atlantic as well. Here's a 2018 installation. This project was in downtown Atlanta. You can see it's about 1 mile east of the Westin Tower. The project actually had 2 basins. We're just highlighting the double trap. I believe one of the systems went under a turf field. The project had a baseball field and a football field. And I mentioned that we're always going to ask to design the system as tall as we can. And I'm going to highlight that right here by comparing the numbers on this slide versus the next slide, which is also an Atlanta project. But this system was 7.5, 52 pieces in 20,000 cubic feet. So the next slide is going to step up that height by almost 4 feet. So you'll see the piece count goes down by 10, and the storage volume goes up by almost 5,000 to 25,000 cubic feet. So this is the Stadium Walk Apartments in Atlanta. This is actually where I lived when I started with Stormtrap. I found out that there was a storm trap in the parking lot at my apartment a few months after I moved in when I was working with the developer on other projects. So I thought it was kind of unique, and I made a slide. But what I'll point out on this slide, if you look over here to the right, you're going to see a couple secondary pores in these modules here. That's we call this an internal outlet control structure. It's very common for us to put this in the design. I would say that we provide this on about 75% of our systems. It saves the contractor from having to purchase a 5 or 6 or 8 foot diameter manhole to control the flow rates out. So we have the ability. You're going to see the spacing between the precast legs here. This is 4 feet. We have the ability to hit basically whatever overflow weir length that you need. I've had a system in Charlotte that required a 30-foot overflow. And what we do is we just use the long legs, so the 15-foot dimension of the module to provide additional overflow weir. And you can see that here. It's kind of small, but there's actually an opening right here that provides additional overflow. Another thing I'll point out on this slide is that there is no mechanical attachment between the end panel and the module. So the only thing that holds that panel in place is the backfill, the earth pressures from the backfill. So during the construction process, we provide the contractor with a couple pieces of number 8 rebar. That's a 1-inch diameter rebar that's bent at a 90-degree angle. And there's actually a couple holes in the top module. You're going to see this coming up, but it basically braces that panel in place so it doesn't fall over during the construction process. Here's a very large system. We gained the ability to go 15 feet tall about 2 years ago. You're going to see a bunch of slides in this presentation that have an 11'4" height. That used to be our tallest system that we could provide. We found the need to provide taller modules for the California market, and we're working on active designs with this height across the country now. But the modules are actually produced in a different steel form, so we actually purchased brand new forms. And the way that you can differentiate them from our current or older forms, I'll say, is these reinforcing ribs on the legs. So this was a very large project in Carson. Carson is where the Los Angeles Chargers have been playing for the past couple seasons. It's just north of Long Beach. But this system was very large, over 700 pieces and almost 600,000 cubic feet of storage. What I'd like to point out on this slide is that the contractor took delivery of some of the pieces early and had them staged and ready for the crane. It's really up to them. I mean, we recommend going right off the truck and into the excavation. That way the pieces don't have to be handled twice. But it's really up to the contractor. They're more likely to damage the pieces if they move them around a bunch of times. But they can certainly decide to do whatever they want. We'll make sure to accommodate them. It's very common for these modules to be designed inside of a parking deck. We're comfortable designing our system inside of a deck or inside of a building. So here's an example from a mixed-use development in Atlanta. This was I believe it was a 2016 installation. Notice the height of this system, 5'6". So that's technically in the range of the single trap. But in this case, since it was inside a building, and really the timing of these projects when they're building the deck is really critical. So it was decided to do a double trap, basically doubling the number of pieces from 35 up to 70 due to installation time. 70 pieces can be set in a day and a half. If you look at the alternate design, which would have been a 5'6" single trap on a cast-in-place pad, you can see this rendering here on the bottom right. It's about 40 feet wide by 100 feet long, and it's got that little funky shape at the end. But it would probably take a good week or two for a contractor to cast in place an 8-inch thick slab. They got to form it up, pour it, get the rebar in there, wait for it to cure. It's probably got to get up to 3,000 PSI before they can start putting concrete on it. So anyway, here's a local project or here's another Atlanta example. Oh, sorry, I just had an alert pop up. Okay, here's the project in New Jersey I was referencing. We don't just have to be a square or a rectangle. We can design to avoid the structural elements of the building. I don't believe that this project ever came to fruition, but it's just a cool example of how we can come up with some crazy layouts. Here's an example of an infiltration system. This was actually a project that I worked on. I took that photo on the right. This is a new hotel. They were planning on having it open for the Final Four in 2020, which unfortunately was canceled. But there is a storm trap system underneath the park next to the hotel. So like I mentioned before, in Georgia, the soils are a little bit better for infiltration. So we see a lot of infiltration down there, which counts as water quality. Here's another infiltration example. This project in New Jersey, various heights. You can see 3'6" up to 5, 48,000 cubic feet of storage. And notice the piece of construction equipment operating on top of the system. That's completely okay as long as we know the specs on the piece of machinery. The tracks on that piece of equipment, they distribute the load pretty evenly. So it looks like they had maybe a foot or 18 inches of cover there. So that's acceptable. And you're going to see coming up excavators operating on top of our modules and setting the modules, which is pretty cool. Here's another infiltration example. This is actually a pond retrofit in New York. You can see it was pushing about 1 million cubic feet between the two basins. But what I want to point out on here is that you can see a large excavator is setting the pieces, so the contractor doesn't necessarily have to have a big crane to set these modules. That piece that the excavator has there is below 16,000 pounds. Infiltration openings in the bottom. We only place the infiltration openings in the interior pieces only, and the reason is due to scour. So imagine if this piece was an exterior wall. It's not. This is an interior wall, but imagine if you had like a 24-inch or a 30-inch RCP coming in to the side of this concrete right here. That peak flow, I don't know how much, 30 or 40 CFS maybe, that's just going to scour out this stone. So we want to have, anywhere there's an inlet pipe, we want to have a solid bottom. So that's why we only put the infiltration openings on the interior pieces only. And these type of pond retrofit projects are a slam dunk for precast concrete because of that void ratio, 91%. They don't have to dig up a whole lot of extra space to replace the pond. Permeable pavers. So it is possible to have a permeable paver system on top of a storm trap system. Now, one thing that we're going to get into some of the joint sealing materials here, but what's typically done, our systems are not watertight by nature. They have the ability to become watertight, you know, with a pond liner or a waterproofing contractor installing a sealant. But generally, what we provide the contractor for installation, we call it an 8-inch wide joint wrap. If you want to look it up, it's called a Conceal product, and you might have seen it before, but it's basically this 8-inch wide sticky joint wrap. And what that does is it prevents water and soil from coming in through the top. There's gaps between the pieces, so it basically keeps soil and water out. Now, if you need water to come in through the top through permeable pavers, you know, it's gonna come down through the pavers, through the stone, through this geogrid here, and then down through this geotextile fabric. They need to eliminate this joint wrap on the top and exchange it with this geotextile wrap. This is an older project. I think it's 10 or 11 years old, and I understand our representatives from our company have been back there to look at this parking lot, and it's looked great. So now watertight, I've mentioned it a little bit. Now, if you might have a couple different reasons why you might need a watertight system. It could be a municipality requirement. It could be a rainwater harvesting system, or maybe a system has high groundwater. Generally, the 40 mil pond liner is going to be the best way to keep water in or out of these vaults. Alternatively, there is an interior sealant, spray-on or trowel-on. There's also a couple foam products. So if you need a watertight system, we're going to have questions. What are the waterproofing specifications? Is the structure going to be filled up and leak tested? If that's the case, like, let me give an example, a project in Durham. They will actually, the systems are required to pass a water test in Durham. I believe they can't lose more than 1% of their volume over a 24-hour period. So in situations like that, we don't recommend the pond liner. If there's any issues with the liner, it's almost impossible to fix. Here's an example of a pond liner in New Jersey. You can see it kind of just wraps up like a Christmas present. On the far right-hand side, you can see over here, there's a custom outlet control structure. And I think you can see what I was describing before, how we can provide additional overflow weir lengths here. I think that's what these openings here are in the top. So I'm transitioning the presentation more towards water quality. So sand filters, I'm sure the vast majority of the civil engineers on viewing the webinar today have designed an above ground or below ground sand filter. I encourage you all to go on YouTube and type Stormtrap, and you're going to see a time-lapse video from this install at the Minnesota Viking Stadium. I think this was about 5 years ago now. But this system is a sand filter installed on a cast-in-place pad. So you can see the time-lapse video. I believe they had to haul in the sand with wheelbarrows. You can see that on the left. Generally with sand filters, we like to keep the height as tall as we can, at least 6, 7, or 8 feet tall. But you can see this system, 4.5 feet, doesn't leave a whole lot of space to walk around there in the vault and you know, exchange the sand when it comes maintenance time. So generally that's not a problem. In North Carolina, we can usually get quite a bit of height. Here's a 2019 install. This one went in the ground last August in 2019. So this is a combination sand filter and detention system. I worked with the civil engineer, obviously a very challenging design. It's got a real funky shape to it. The system was a combination single trap and double trap. The single trap was 7'6", the double trap was a foot taller, and the invert of the single trap was actually up a foot higher. So they had to make sure to install the double trap first, and that's what you see here on the right. This is the sand filter chamber. So if you look down here to the bottom right on the rendering, the module is going the opposite direction. That is the sand filter chamber. To the left, this is the sedimentation chamber, and to the right, this is the detention chamber. And the system had an internal outlet control structure as well. So if you look at the openings here on the double trap, this is the interface between the sedimentation chamber and the sand chamber here on the right. And then these openings on the left here, those are the overflows to the detention. So basically any water that comes into the system, unless the structure fills up over this elevation here, everything is forced by gravity through the sand media. Here's another example in Chapel Hill. This one, I believe, was 7 years ago. Very large system for a church. These sand filters can be designed very different ways. I've seen detention upstream, downstream. Sometimes they're required to have a hanging baffle wall. So there's various designs. This is probably the most common one. So I'll briefly go through how it works. So all your inlet pipes are going to be directed to the sedimentation chamber, which on the photo on the left is the bottom portion of the system. This is a permanent pool. Water is going to overtop this wall. It's generally a 3-foot tall wall. We call it a knee wall. And then water is going to build up over the sand and be filtered. Now, it's very difficult to see, but on the top left, you're going to see a green geotextile fabric or a filter fabric. Very hard to see, but there are holes in the side of the concrete up here, and that's where the overflow occurs. So once the sand filter builds up to the water quality volume elevation, the stormwater is going to spill over into the detention portion of the system. And as you can see, the back portion of the system, where you see the joint sealant and the top modules installed, that's the detention portion. So it's very common for us in North Carolina to design the sand filter, the sedimentation chamber, and the detention in the same vault. Now, if you have a monster detention volume and you can get a taller height, like maybe 11 foot, that's a really cost-effective size, 10 or 11 feet tall, it makes sense to separate the detention from the filter. There's no reason to go taller than 8 feet on the sand filter, really, because North Carolina, the maximum ponding depth allowed is only 6 feet. Here's an install in Durham. I mentioned that these systems are required to be filled up and leak tested. This was a hotel. I believe it was a Best Western and a Ramada, changed names a couple times over the years, but it was torn down, and they constructed luxury apartments. Unique sand filter design here. You can see on the bottom right, the system had a triangular shape. And another thing that was unique about this system is that the sand filter chamber was stepped down 2 feet from the rest of the system. So it's actually very common for our structures to have different invert elevations, which it's possible. Makes the installation slightly more difficult, but it's definitely doable. Biofiltration. So precast concrete modules by themselves, they're obviously not green infrastructure or LID, but I can show you how we can act in tandem with a biofiltration cell. This is an outpatient center in Illinois, so water sheet flowed off the parking lot into the swale, and then there were some catch basins underneath that allowed water to get into the storm trap. Rainwater harvesting. If you have a project that is maybe going for lead points, there's quite a few points available for water reuse. This is the largest project you'll see today, 1,200 pieces almost, and then almost 800,000 cubic feet of storage. This project holds the record breaker for the most amount of pieces installed in one day. They were able to set about 90 pieces a day because the modules were staged on site and they took delivery early. The installation process with a crane, it's really limited by the precaster's trucking capacity. It's time consuming and labor intensive for the precaster to load the modules on the truck. They got to strap down the loads, there's paperwork, traffic and things like that. So generally when we send out bids, 40 to 50 pieces a day, the contractor can back calculate and figure out how many days of crane they need. I mentioned that the systems can be installed with an excavator. The capacity is a little bit less we recommend 2 excavators, one to offload the truck and one to set them. You can see here they're setting the module from on top of the system itself. Here's a cool time-lapse video of an installation. This project was an intermodal facility in Illinois. I want to say it was in the Chicago area. The system was designed for HS25 loading. Basically the difference between the HS20 and the HS25, the HS20 truck has 32,000 pound axle loads, and the HS25 truck has 40,000 pound axle loads. So obviously this is a shipping container site, so lots of heavy truck traffic. That's why you see the cast in place slab foundation. They were able to set this whole system in a day. You can see the laborers rolling out the joint wrap here. So usually they can set the equivalent of 30 to 40,000 cubic feet per day. So whatever that equivalent is, as long as it's a taller system, they're usually setting about 30 to 40,000 a day. Some of the joint sealing materials, I've touched on this already. The material on the right is the joint wrap, 8-inch wide sticky joint tape. And then the stuff on the left, that's called a butyl mastic joint sealant. And that stuff is used in any type of precast structure, whether it be electrical, telecommunications, sanitary. That's pretty standard stuff. And it's installed on the exterior joints, and it's also used on the interior pieces as well. Some of the different features we can provide, we've seen various types of outlet control structures. We provide MA Industries PS3 steps. They're 16 inches wide, so they're very safe, and they're drill-in steps, so the precaster will have to drill those in and install those after the piece is poured. Access points. We get a lot of questions about, hey, where should I put those? So usually what I tell engineers is to space them. It depends on how deep the structure is. You want to think about the length of a hose on a vacuum truck. So if you have a system that, it's 15 feet tall and it's got 30 feet of cover, then you might need some more access points on there. But generally 30, 40, 50 feet apart. Around the outlet control structure, you generally want to have one on the downstream and one on the upstream side of that weir. Precast concrete can be installed in poor weather conditions. So if you would compare this versus like a pipe system, they need select backfill that has to be compacted properly. And if it's raining really heavily out, they're not going to be able to get the compaction. They might not be able to continue on with the installation. That's not really an issue with our precast modules. Maintenance. So eventually these systems are going to need to be maintained. It's obviously best to put in a pre-treatment type structure like we're going to get into here in a minute, but there will be a lot of sediment that settle in these underground structures. So with our precast modules, it's very easy for a person to pop off the cast iron manhole lid and crawl down those steps and access the system, perform maintenance activities and things like that. If you compare us versus some other solutions out there on the market, especially any type of a plastic system, those are extremely difficult to maintain and access. So these are much easier. Now, I would say probably 1/3 to half of the engineers on the call use HydroCAD as a stormwater modeling software. There is a chamber wizard in HydroCAD with various types of products. You name it, it's in here. StormTrap is in here. I use the tool myself to come up with a quick layout if I'm talking to an engineer. The only thing this doesn't allow you to do is to block off individual modules. So it limits you to a square or a rectangular shape. But if you're over on your volume, just give us a call. We'll come up with a custom CAD file for you and you can slap it on the plans, no problem. Okay, so Site Saver. Now, this is a hydrodynamic separator. These types of systems are not approved by NCDEQ, but somehow I see them on plans occasionally in North Carolina. I've seen some in Gastonia. We've seen some in Asheville, as well as Eastern North Carolina in the Fayetteville area. So these types of structures, like I mentioned before, they're effective at 50 to 300 microns. All of the manufacturers in this industry have some version of this structure, whether it's a swirl concentrator. Most manufacturers will have a hydrodynamic type of system. We've gone through all the necessary testing to be approved by NJCAT and NJDEP. They actually have a list of approved manufacturers, and they assign approved flow rates to each of the individual models. So whenever an engineer is comparing different types of water quality structures, whether it be a proprietary filter or a hydrodynamic separator, I always instruct engineers to reference New Jersey, because all of the manufacturers have to play by the same rules. They have to run the same artificial sediment through the systems. So this is how ours works. It's got a net on the front end to capture leaves and floatable debris like plastic and things like that. But the main removal of the system occurs with the inclined plates. So we have the ability to add plates in the system and treat additional stormwater flow, sorry. So we have 4 different model sizes, from 4 CFS up to 20 CFS. You know, that's quite a large range of flows there. The SiteSaver can be used as part of a treatment train. So in Maryland, let me give an example. In Maryland, MDE has pretty strict stormwater requirements. You see a lot of treatment trains, which would be a hydrodynamic separator with a storage system, followed by some type of a filtration device. We see a lot of that up in the Mid-Atlantic area. So that can be done in North Carolina as well. But like I mentioned, the SiteSaver and those hydrodynamic structures aren't officially approved. So why is stack cell sedimentation better? That's the technology that the SiteSaver uses. Well, I can compare to an equivalent size swirl concentrator unit. So for 4 CFS, our smallest model, you might be looking at a 5 or 6 foot diameter swirl concentrator structure. When we go up to almost 20 CFS, 19, 20 CFS, our structure stays in that 6 by 14 footprint, when the swirl concentrator might get up to maybe a 10 foot or a 12 foot diameter manhole. So lots of installation cost savings there. That's why it's called the SiteSaver, because we treat a lot of water in a small amount of space. Here's a quick case study. This system was installed in Atlanta in the fall of 2018. It pre-treated a 9 foot tall precast detention system. Here's a couple photos of the installation. It does not come assembled. So the contractor will need to set the base vault in the ground. Heaviest pick weight on these is about 22,000 pounds. So it's right on the upper limit of what a large excavator can do. They'll have to bolt in the stainless steel or aluminum internals. They'll need to install the net, grout in the pipes, put the top on, and it's ready to receive stormwater. Nets. We get a lot of questions about, can you reuse the nets? And we always mention this analogy. Would you reuse the trash bag in your kitchen? Probably not. So it's best to just change out the net and put in a fresh one. The net is $300 to $400 depending on the size. The standard net size is 30 by 30 inches. So trash trap. So if any of you civil engineers on the call that are maybe working with municipalities, there may be a need to target trash. Trash trap is a product that can help. A Baltimore study found that a lot of the trash is actually cigarette butts, which is kind of surprising, even more so than food wrappers, beverage bottles, cups, straws, and things like that. Henderson Island, one of the most remote places in the world, right up there with Hawaii, completely uninhabited, but it's the #1 place in the world where plastic debris washes up on shore. And I've seen reports about trash washing up on our West Coast and as well as Hawaii. So trash is certainly a problem. I remember living in Houston. I used to live on one of the bayous, and one time I saw a bubble screen TV floating down the bayou. So people just throw stuff away, unfortunately. Trash trap applications here, 3 different configurations: inline, end of pipe, and floating. So I'm going to give you a couple examples here on this. But first I want to mention that it's always more cost effective. And when I say always, I mean 95% of the time, probably. Put one large treatment structure at the end of the pipe versus trying to treat at each individual catch basin or curb inlet. And that's the case with SiteSaver and hydrodynamic separation as well. Same applies with trash trap here. The inline module, this system, this rendering doesn't really do the product justice. Yeah, we can provide a 1 net system, but some of these systems that we provide are very large scale. We got quite a few installations in the Newark, New Jersey and New York area where trash is a big problem. They'll usually have a lockable access door on the top, or they'll have a heavy duty cast in place lid. You can see that little excavator either picking up or putting down that lid. Those probably weigh 400 or 500 pounds. So you need special equipment to get in there. But the system is out of sight and out of mind. The photo on the right here, this is fresh after a maintenance event. And we provide this fiberglass drain grating on the bottom. If you can see my cursor here, it kind of looks like that black thing with lines going up and down. That basically prevents the nylon nets, just it kind of stops the abrasion between the concrete bottom of the manhole or precast vault. This is the end of pipe module. So this is going to be exposed. It's obviously going to have to be locked, and measures need to be taken to keep people out. So here's an example in LA. California actually has a trash mandate. So we do a lot of these types of systems out in the LA and California in general. You can see the preconditioned trash is getting out, and they got that grate on there to keep people out of that 72-inch RCP storm drain. And the photo on the right, you can see the completed system. It's got the, I don't know what you call it. It looks like prison bar cells, keeping people away from tampering with the nets. And also trash is being captured. And the floating module. So I'll be honest, not very aesthetically pleasing to the human eye, but this will prevent trash from escaping. So this is used if your outfall pipe is submerged underneath a lake or a stream or a river or something like that. It's also used when the flow velocity is too high to use the two previous configurations. So where we draw the line is about 5 feet per second. If you're more than that, then we're probably going to have to look at doing something like this. Here's an example in the Mid-Atlantic. The Anacostia is a branch of the Potomac River, meets up with the Potomac around the Navy Yard near the Washington Nationals baseball stadium. It's estimated that the Anacostia receives 20,000 tons of trash annually. It's kind of hard to imagine that, but a system like this can help. You can see the drain curtain basically just forces the trash through the nets there. Sometimes in these install photos, you'll see like a boat. Sometimes they need to get the trash from outside there, but again, this will stop trash from getting downriver. Maintenance of the system, what's cool about it is that you can weigh the trash and count it for TMDL reporting. Maintenance is pretty easy. They're going to need a jib crane. The nets weigh about 1,000 to 2,000 pounds when they're full of trash. So special equipment is needed to lift that. You're not going to lift that out with your back. So if you have any trash inquiries, just let me know if StormTrap can help. And then Pump Guard. So this is a wastewater product, and it's very similar to Trash Trap, except the nets are stacked on top of each other. Here's some of the components, but basically it's a stainless steel bracket that's bolted in place into a cast-in-place channel. Most of the time, these systems are installed after the bar screen rack. They can also be installed in a precast manhole or in a lift station. So here's what we're trying to stop from getting to the pumps. Birth control products, ketchup packets, floss, personal hygiene products, and the flushable, Kroger, Lysol, Clorox, wipes, Aldi, whatever. Those things, they don't break down. People flush them, and you get situations that look like this and pumps that look like that. As a fair heads up, the next slide is kind of nasty, so hopefully everybody's done eating their lunch. You've heard of an iceberg. There's such thing as a fatberg. This is a blockage that occurred in London, an 800-foot-long mass of wipes, oil, and grease. So this is just gross, and it really creates a nasty situation for everyone, the environment, animals, people. There's the Baltimore on the right. Installation of the system, it goes in pretty rapidly. The plant doesn't have to shut down for an entire day to install this. It's pretty rapid installation. Maintenance, again, you don't want to reuse these nets. These will be hauled off to a landfill. These photos here are from the case study on the next slide. This is the 6th largest wastewater treatment facility in the country in Newark. This Basic Valley Sewage Commission services 1.4 million people per day. The flow rate into the facility is 750 million gallons per day. So you can imagine that those pumps are very expensive. And then you can see they change 16 nets once a week. They remove 17,000 pounds of stuff per month. And you can see the little bullet point there. The facility in Indiana changed them once a month on a different project. So wrapping up the presentation here, if you contact StormTrap and if you have any underground systems that you'd like to engage StormTrap on, we generally turn things around in about 2 to 3 days. Now, if it's a complicated sand filter, it might take a little bit longer than that. we'll get you a PDF and a CAD file that you can slap on the plans. And then installation services, we do have a project manager that will be on site during every installation. Our average lead time is about 6 to 8 weeks, but it totally depends on the amount of modules. I mean, you saw an example with 1,200 pieces of concrete, so that would obviously take more than 6 to 8 weeks. And we can, engage different precasters to pour one basin for us. So we have a couple different options to meet your client's timelines. And then maintenance, we do offer the replacement nets, and we work with a company called Telnet. So there is an app for that, for an owner to basically log into their app and figure out how much trash is in their nets. And I encourage you all to go online, check out our website, sales territory maps, case studies, and things like that. There's also a link if you want to request a lunch and learn at one of your individual offices. I cover all of North Carolina, from all the way out to Asheville to Wilmington, Winston-Salem, down to Charlotte. Just let me know if you'd like me to come to your individual office and do a presentation for your colleagues. And I encourage everyone to connect with Stormtrap on social media. Feel free to connect with me as well. I know that we will be doing we do about 8 LinkedIn blasts per territory per year, so you can see cool projects that are going on around the region. And so that wraps up the presentation. Here's my contact information. That's my direct cell phone line and my email address. So if I can help you in any way, please let me know, and we can open it up for questions now. Katie?
All right, great. Thanks so much, Aaron. So we do have 2 questions already, and then I encourage you, everyone listening, if you have a question, go ahead and type it into the box. The first question is, have Stormtrap products been used much in transportation projects? If so, do you see them being used more by municipalities or by DOTs?
So Katie, I know for a fact we've done quite a few DOT projects. We did one in 2020 in Maryland. We've also done a bunch in the Chicago area. I don't know if we've done any for the North Carolina DOT. And as far as Virginia goes, I believe we had one proposed on a Virginia DOT project, but I don't think it ever came to fruition. But we do work with municipalities. So we have a very large system in production right now with 300 pieces for the city of Wilson, and that was purchased directly by the municipality, and that will be installing exactly 1 month from now. So we do have the ability to come up with a design for a DOT or a municipality.
Okay. We have another question. How do you clean and maintain the sand filter?
So the way that it works, we don't do the maintenance ourselves. So we would work with a third-party maintenance company. But my understanding of when they maintain the sand filter, what they do is they will take off the top bit of sand that's, I guess the word is occluded with the pollutants. So they're normally not taking out the full 18 inches of sand. And I also want to mention that the depth of sand does vary. So the taller sand you have, probably the longer maintenance cycle you can go with before a maintenance would be needed. But generally, a hydrovac truck will be used to basically suck off the top 3 or 4 inches of sand and haul it off to a landfill. But I personally have not seen that done, but I would like to.
Okay, I don't see any other questions. We'll just give it another minute to see if any come through. Let's see. Okay, so just a quick few PENC announcements. Your PDH and NCBELS forms will be emailed to you this afternoon. The PDH record is for you to keep. The NCBELS survey needs to be filled out and returned to me via email. I don't see any other questions coming through. So if you do have another question, feel free to reach out to Aaron directly. Aaron, thanks so much for being here today. I hope you all will join us next Wednesday for corrosion control and the triple bottom line. You can see our entire lineup of webinars at penc.org. Aaron, thank you again for being here.
Thanks, Katie, and thanks to everyone on the call.
Have a great day, everyone. Bye-bye.